Hi, this is your host Swapnil Bhartiya and welcome to a brand new episode of TFR Let's Talk. And today we have with us Allen Proithis, CEO of GXC. Alan, it's great to have you on the show.
Well, thanks for having me.
I would love to know a bit about, first of all, your own background because you do have a very long background in the telco space. And then also, GXC, how do you look at the company? Why you felt that, hey, this is the company you wanted to lead?
Sure, happy to. And it was my pleasure to join as CEO of GXC about 3 months ago now. I actually had my 3-month anniversary this week. No time for cake, though, because we have so much going on. But I've been in the mobile and the telecom industry for quite a long time. Previous roles include being the founding president of SIGFOX North America, where we deployed a wireless IoT network for low data devices covering about 70 million people. Being an officer in a NASDAQ company, InterDigital, that's the leading independent creator of wireless IP in the world. And spending a number of years at HP, where my last role was leading business development and strategy globally for mobile. So have been involved with the entire mobile ecosystem for quite some time. And frankly, I was very fortunate when I first started my career that it was when mobile had just started. We were growing at 80% subscribers a month. And, it frankly is more exciting than ever.
And if you look at your career graph, and if you look at the evolution of technology in the telco space, all the way from the hardware, black boxes, they have moved to white boxes, they have moved to a lot of open source, software-defined virtualization technology. Can you talk about what kind of evolution have you seen of this space?
Well, it's absolutely probably the biggest, most dramatic evolution of any technology in human history, if you think about it. Not to diminish the importance of the wheel or the steam engine, but or electricity, but if you just think about this little device we all carry with us now, and people forget that as recently as a dozen years ago, we weren't even at 50% smartphone penetration in the U.S. And so when you look at as many technologies are evolving, they start out with very proprietary, super expensive things. Remember who's ever going to need a computer at home? Because back years ago, they were these big, massive things that took up rooms. And with enough time, here we are where everybody has the most powerful computer in the world in their pocket almost to do everything. So I think the trick now is how do we apply these things? Like anything, these are tools. They're neither good nor bad. It's really how they're applied by the individual, which makes them good or bad. And I think, frankly, we're just at the beginning of the curve of really understanding the best way to apply all these technologies.
If you just go back to the market itself, with this evolution and also the amount of traffic that is flowing is also changing, massive amount of traffic, data is flowing. Can you talk about what are the challenges, what are the problems that modern providers face when it comes to connectivity?
Sure. It depends on your filter, how you look at it. If we go back a few decades, data traffic was about 10% of everything in traditional telecom networks. And today, it's pretty much almost all of it, especially if you have children of any age or even young adults. Good luck getting them on a voice call versus some kind of data exchange, right? But I think we've had some pretty big changes in the way we think about data. Because as recently as maybe 10 or 15 years ago, when you had a company, it was, how many blade servers can I stick in my basement? And then it went to, okay, how do I never own a server and get everything in the cloud? And I think people are realizing now the answer, like many things, is probably somewhere in between. And it really depends upon the application, the type of data, and where you're at as a company. And I think that's really one of the most powerful things about the virtualization tools that are now maturing very quickly, and the open source tools that we've really enabled at a much lower level. You don't have to be Amazon to have these tools anymore. Maybe you get some of the tools from Amazon, but the power in the individual's hands is just amazing to determine how the data is being processed, where it's being processed, really how you're going to run your business. And I think we've really are just getting started with that revolution.
Since we are talking about evolution, I also want to talk about what role do private network providers play in this big ecosystem? Because once again, the market is huge. We can talk about private 5G deployment, we can talk about edge, we can talk about IoT, but let's talk about in this whole movement that we just talked about, the role of private network providers like GXC.
Well, I think we start with a couple fundamental concepts. So first of all, most cellular coverage traditionally is outside, and most wireless data consumption is inside. So a little bit of a problem with that, first of all. Second of all, a public network is made to be a network that really covers everything for all people. It's not optimized for any one particular thing. It's to be the everything network. Sort of like the post office, right? You can get bills, you can send cards to your mom, but if you need something really important, you're probably going to call FedEx or UPS, right? And traditionally, that network is not made to be any particular thing. When you get into private cellular networks, we think about it as the third enterprise connectivity layer. That you have a traditional Ethernet layer, you have a traditional Wi-Fi environment, which is great for what it was made for. The challenge is the demands of many business critical applications are simply not met by the existing connectivity technologies. So there's absolutely a place for them. They're not going away. In fact, they'll continue to deploy. We're not trying to compete with them, frankly. But when you go to a warehouse, when you go to a manufacturing campus, when you go to venues or transportation hubs, and they're trying to do everything on this network that was really designed not to do that, you need something different that provides the coverage, the security, reliability, and low latency that Wi-Fi just fundamentally wasn't architected to provide. And so that's the way we think about it, and that seems to be resonated extremely well with our partners and customers, that keep all that existing, connect your laptops to it, use it for certain things, but for the things that are critical to your business operations, to give you the control of your data where it doesn't have to go in the cloud, to give you the latency you need to do some of the most exciting things around AR-driven maintenance and repairs, especially with the problems everyone's having hiring. You just can't do it with existing connectivity, and that's why these private cellular networks are so important.
As you were giving example of, sometimes you have to go to UPS or FedEx also. Are there specific use cases or industries where, private cellular network makes more sense, or you feel that, hey, it doesn't really matter. It has to be, once again, it's Wi-Fi and Bluetooth and cellular and private cellular network. How do you look at it?
So let's start out by saying where it's not a good fit. So let's take a traditional office environment, carpet on the floor, desks. You have Wi-Fi everywhere already. You don't really need a private cellular network for what you're doing in that environment. And again, I have a little bit of heartburn when I hear people talking about private cellular is going to replace everything, because it's not. There simply isn't enough spectrum. So that's probably not the best use case. But once you get rid of the carpet and you go in the warehouse, you go in the campus, you go in a venue. One of the reasons, like for instance, airports are looking at this so much is that they put Wi-Fi everywhere, but a lot of times the passengers use the same Wi-Fi network as the vendors have to report sales every day for rev share. You don't want to run your ticketing systems, on the same networks that passengers are watching HD videos of pandas sneezing. Okay. Same thing when you get in the warehouses. Like for instance, interesting statistic, because we're doing so much work in the warehouse space. In California, it's at or over 70%. Other places are right behind that in terms of forklifts being electric. Just knowing the charge on your forklift, because if that thing runs dead, you don't have a warehouse operation anymore. It's a fundamental part of your business. Driving the scanners, driving the solar systems. We see manufacturing campuses you have corporations that have their own homegrown applications. They want to have seamless connectivity inside and out. They control where the data goes. They want to upload it later to some cloud provider. That's great, but they're in control of their data. And so there's all use cases that all circle around the concept of business critical connectivity.
Are there also any use cases, or because sometimes a lot of innovations happen because of any specific technology is not accessible or available? A few years ago, US government they released some 5G network bandwidth. They made it more inexpensive to people to spin out 5G private networks as well. Do you also see that because of this latest technologies, innovations, and private cellular network, a lot of you did give some example but you see that, hey, these are the use cases which are now enabled because of that, where companies were not able to do something earlier?
Sure, I'll embrace my inner geek now for a moment, given the question. The U.S. government a couple of years ago allocated spectrum around a 3.5 gigahertz band called CBRS. And basically, it's 150 megahertz that is a shared spectrum you can use for 4G and 5G services. So think about Wi-Fi. When you get Wi-Fi, you buy a box for your home or office, and you plug it in. You don't call the FCC after you buy a Wi-Fi box and say, hey, can I have some bandwidth for this? There's a piece of shared spectrum that you have to use according to the rules, but everybody can use it as it's available. And that's what this spectrum is for CBRS. And so what it in essence does is it allows anybody to operate a private cellular network. Most of these networks today are going to be LTE simply because there's not very many devices on the 5G side. There's not use cases yet to justify that much of the pure 5G. And by the way, we run the 5G lab for the US government in Coronado. So we do 5G today, but from a customer standpoint, the price performance around an LTE network is actually a better spend for them. So the availability of that 150 megahertz of spectrum called CBRS is what really is enabling what's a renaissance in private networks. And to give you some sense of how big the impact is, this is not taking off around the world. If you go to the UK, you go to Germany, you go to other places, they're all coming up with their own version of how people can share spectrum. And there's a lot of talk, nothing's finished from the rumors I hear, of future government spectrum auctions rather than doing the traditional give us tens of billions of dollars and we'll give you a chunk of spectrum. There's some serious interest in licensing even bigger bands of shared spectrum because it allows everybody to use it and promotes technological development in the U.S. And of course, I'd be neglectful if I didn't mention our specific piece of special sauce we do, not just with this band, but many other pieces of spectrum. That one of the things that makes us very different in the private cellular space is the concept of a mesh network. And so you probably have mesh Wi-Fi at home, right? Because the old days you plug in your initial Wi-Fi gateway router and you plugged in your backhaul to it and you try to put these repeaters up, and depending if the neighbors were using it, maybe it sort of worked, and if your kids tried to game, forget it. And then we got mesh and Wi-Fi, where you just had to plug the rest into power, and they communicated very effectively to provide that coverage. We have a lot of patents and a lot of IP around doing enterprise-grade mesh cellular network, where it does in-band mesh, reuses the spectrum, so you can put your core network in and access points with backhaul, but then it gives you flexibility to extend that very easily, just plugging in another node wherever there's power. So when you get into some of these larger manufacturing campuses, you have to cross a road. Or we working with some building product companies that when they saw the hurricane coming in Florida a few weeks ago, turned up the crank to manufacture, because it's going to take years to rebuild all this stuff with this terrible tragedy. Well, they're storing all this stuff in areas that they never had stuff before. So you need to inventory, you need to move it, manage it, you need to maintain and monitor it. Well, what are you going to do? Get a backhaul and put a big trench in? To put backhaul in, with a big backhoe? So the ability to have a very flexible extension of the edge of the network that also is self-healing. So if a node goes down, it just hops like it would in a cellular network to the next best node. Or if a big metal truck parks in front of something, or someone, not the forklifts do this, but when a forklift shears a pole over, the network just keeps going. And so that's another very exciting attribute of our network that helps the private cellular space.
This might be a totally off-topic question, but I want to throw it out to you, which is more or less like, if you look at these EVs, autonomous cars, they are also hungry for data. Do you think that there might be a possibility, just the way we have mesh network, private networks, inside of buildings, inside of organizations, there may be such networks on the road as well, because we will need that kind of connectivity at some point on the road as well?
Well, I think we're only limited by our imagination. So I think there's two separate questions there. One is autonomous type of things, and the second is sort of dynamically formed networks with things in motion. So let's take those one at a time. So from an autonomous vehicle space, you can't do it with Wi-Fi. Okay, it just doesn't work. And if you look at, again, our long-term secular employee shortage, COVID sort of jump-started a lot of automation and robotics, but what we're seeing now is you're going to see that even going harder and faster with what we're experiencing in our economy and, in fact, the world. So these private cellular networks become a key enabler of all that kind of robotics technology. I would also say to you on sort of the autonomous thing, if you look at the autonomous developments in agriculture and in factories and in warehouses, they're going to lead what happens with consumers on an open road by decades. Because simply put, it's a controlled environment. When you're driving a multi-million-dollar tractor down the field, it's easy to use computer vision to sense of a child or an animal or a tree fell down or something, and you can stop and signal the farmer at 3 a.m. Because that's the goal of these things. You're spending millions for these big pieces of basically it's a mobile edge compute platform on really big tires at this point. And you want to keep that thing running. And there's fields in Iowa and Idaho, you can drive 10 or 20 miles in a straight line. So you want to keep that thing running day and night. And, we're already looking at use cases where you put a mesh node on one of these things because you have so much data. And so you're meshing together with the other things around to get the data back and provide the information you need. Same thing with warehouses and other things. So then we get to sort of the open road. It's the hardest situation, as we know, because there's so many variables. When you're in a controlled environment, you have a fraction of the variables. So will we have these mobile mesh networks? I think it's TBD. I mean, there's a lot of technologies that some of the big guys have looked at, like V2X and stuff, to sort of help enable some of these mobile use cases. But it's really dependent upon a lot of really technical things, like where in the spectrum you can use that bandwidth for these kind of networks, how much of the spectrum you get, the speed at which you're even traveling. Like, for instance, when NB-IoT came out a few years, like for IoT stuff with cellular connectivity, like it does really well, like when you're below a certain speed or above a certain speed, but in the middle, it doesn't really connect very well. And all these technologies have their strengths and weaknesses, and I think it's going to take some figuring out to get the right mix for some of these use cases.
Yeah, you're absolutely right that we are limited only by our imagination. We have no idea where these technologies will take us. So it's a very exciting future ahead. I want to scale back and talk about GXC one more time. Can you talk about what kind of solutions you folks offer to help these wide range of use cases, and how different are these solutions from other players?
Sure. So again, we're a little bit different in that we're an integrated turnkey solution out of the box. So the thing we're trying to avoid is a lot of times people have a piece of the tech and they say, you just got to put a couple of things together. It's sort of like saying your house is down at Home Depot. You just got to put it together when you have some time. It's people just want to get the business value out of it. They need to understand how it works, but if you can't get the business value out as quickly as possible, it reduces the value of the solution. And frankly, in a perfect world, we'd be invisible all the time, just working, doing our thing in the background that enables all the important use cases. So we approach it from a very turnkey, integrated solution. When we did a demo at an industry conference just 2 weeks ago in Las Vegas, we actually had our basic solution up with an access point and a mesh node in 30 minutes. Try setting your Wi-Fi up at home in 30 minutes, right? So we're actually going to make a video of this soon just so we can show people and do a time-lapse thing. So it's a real differentiator that you can literally just throw up a bunch of nodes and be running very, very quickly. The other approach we've taken is that a lot of times when you come at life from a technology side, you think that I am the center of the universe. And I hate to tell everybody, but we're not, okay? Your technology is only important as to the benefit it delivers. And so we've approached the world as any environment we go into is going to be an existing operation of some type. So nobody's going to change for us. We need to be flexible enough that it's easy to work with us rather than try to impose anything on a customer. So we're built from the ground up as sort of enterprise-ready integration with the architecture of APIs that we have. So it's very, very easy to integrate on a control or a data basis with any existing system people have. So if there's a certain management system they use now, getting data in the right place, whatever it is, we're architected out of the box to do that, to try to make it as easy as possible to get the value out of it versus focus on the tech.
Alan, thank you so much for taking time out today and not only talk about your own journey, but also share some insights about the industry, the challenges, the problem, and how GXC is helping. And also, I love your insights on the use cases, how it is being used, and what use cases it might enable in future. So thanks for sharing all those, and I would love to have you back on the show. Thank you.
Well, thanks for having me. It's great to be here, and I think the best is yet to come, so hold on.